The next problem which we have is a pretty interesting problem of ionic equilibrium. We need to find the pH of a solution when 0.2 moles of HCl is added to a solution, to a 1 liter solution containing the first part 1 molar acetic acid and 1 mole of acetate ion, and secondly 0.1 molar acetic acid and 0.1 molar acetate ion. Now first solving for the first part, we have acetic ion concentration and acetic acid concentration both equal to 1 mole. Initially, when HCl is added to the solution, this will react with acetate ion to give acetic acid. This was 0.2 initially when it was added. This was 1 mole. This was 0 and 0, or rather it was 1 initially because it was present 1 mole of each of acetic acid and acetate ion. This was 1 mole initially. This being a strong acid completely reacts with this. If 0.2 moles of HCl reacts, then 0.2 moles of CH3CO2 negative ion will also react. So 0.8 moles will be left and 0.2 moles of acetic acid will be formed. This will be 0.2. Now the final solution which we have is comprising of 0.8 moles of acetate ion and 1.2 moles of acetic acid. So here a buffer is being formed between acetic acid and its base, and hence the pH can be very easily found out by using the formula pH is equal to pKa plus log of salt upon acid. Here the Ka for acetic acid is given to be equal to 1.8 into 10 power minus 5. So we can calculate pKa to be equal to minus log of Ka, that is minus log 1.8 into 10 power minus 5 plus log of salt which was acetate ion, that is 0.8, divided by the acid which was acetic acid concentration, that is 1.2. On solving this, the pH comes out to be equal to 4.5686. For the second part, we had 0.1 molar acetic acid and 0.1 molar acetate ion present in the given reaction mixture. For the B part, let us consider the reaction of HCl with acetate ion. This gives acetic acid. Initially, this was 0.2, this was 0.1 and this was 0.1. Now the number of moles of HCl in this part is greater than the number of moles of acetic acid. So acetic acid will be completely reacted and 0.1 moles of HCl will be left in the reaction mixture. This will completely react to give 0.1 moles of acetic acid. Now in the given final reaction mixture, we have 0.1 moles of HCl and 0.1 moles of acetic acid. Now acetic acid being a weak acid and also in the presence of a very strong acid HCl, it dissociates. But the H plus coming out from acetic acid will be very less as compared to the H plus ions which are coming from HCl. So we can neglect the number of H plus ions coming from acetic acid and consider the total H plus ions to be equal to just the ones coming from HCl, and that is equal to 10 power minus 1, and hence the pH will be equal to 1, and hence the final answers for the pH in the two cases are 4.5686 and pH equals to 1, and these are our final answers.